Let's do question number 6, building a polynomial with specific conditions. Part A says, find a third degree polynomial function with integer coefficients and the zeros of 2/3 and 2 iota. So let's write all the zeros. There should be 3 zeros because the degree is 3. 1 0 is 2/3 and 1 0 is 2 iota. 2 iota is a complex number. If 2 iota is a 0, then its conjugate is also a 0, which is negative 2 iota. So we have the factors x minus 2 by 3, x minus 2 iota, x plus 2 iota. These are the factors of the function. Let's simplify them. X minus 2 by 3. If you multiply these two, you will get x square minus 2 iota x plus 2 iota x minus 4 iota square, that is using distribution, x minus 2/3. This cancels, and for your reminder, iota square is always -1. Use that. So we will have x square minus 4. You can simplify it further by distribution. You will have x cube plus 4x minus 2 by 3x square minus 8 by 3. Now let's read one more time. The function had to be a third degree polynomial with integer coefficients. So you see here, this does not have integer coefficients. So I can write this as 3x cube plus 12x minus 2x square minus 8 by taking denominator. So I want to consider the function which has all these zeros. I can multiply this whole thing by 3 and get my function to be something like this. I can multiply this by 3 to get rid of that denominator because I want the integers, coefficients, right? So this is one of the functions possible which has degree is equal to 3. It has integer coefficients and zeros are 2 by 3 and 2 iota and negative 2 iota. Next we have Descartes' rule of the signs. What does that say? If f of x be a polynomial with real coefficients and non-zero constant term, that means all the coefficients are real and constant term is non-zero, then the number of positive real zeros is either same as the number of sign changes in f of x or less than the number of sign changes in f of x by a positive even integer. What does that mean? The sign changes. Okay, let's I want like to teach this using an example. Let's look at example number 7. Function f of x is given as x raised to power 5 minus 6x raised to power 4 plus 12x square x cube minus 12x square plus 11x minus 6. Let's just look at first the possible positive zeros. Okay, what is it saying? The same as the number of sign changes. What does sign change mean? From the first term to the second term, if the sign is changing, we count it. Now from negative to positive, again the sign is changing 2, positive to negative 3, negative to positive 4. Again, so there are in total how many sign changes in the polynomial? That number is number of sign changes is equal to 5. 1, 2, 3, 4 and 5. Okay. We are saying the possible number of positive real zeros is same as the signs changes, that is 5, or less than that by a positive even integer. What are the positive even integers? 2, 4, 6 and so on, right? So what is possibility for number of possible positive zeros? What are the possibilities? Either 5, or 2 less than 5 would be 3, or 2 less than 3 would be 1. We cannot reduce another even number because that will become negative. We cannot have negative number of positive zeros, right? Let's look at the second part. Number of negative real zeros is either the same as number of sign changes in f of negative x. So the first step we will have to do for number of possible negative zeros, we will have to find f of negative x. How do you find f of negative x? In the function, change negative x in place of x. Negative x raised to power 5 minus 6 negative x raised to power 4 plus 12 negative x cube minus 12 negative x square plus 11 times negative x minus 6. So f of negative x is negative x raised to power 5 is negative x raised to power 5 minus negative x raised to power 4 will become positive because even power makes negative positive. So this is my function, okay. Let's note down sign changes. How is the sign changing? Is the sign changing here? No. Negative 6 to negative 12? No. No sign change, right? So no sign change is happening. That means possible number of negative, let's read one more time. The possible number of negative real zeros is the same as sign changes in f of negative x, or less than that number by a positive even integer. Now in this case there is no sign changes f of negative x. So possible number of negative real zeros is equal to 0. Okay. So what is the possibility? We said let's make a table. What are all the possibilities? For the given function, possible number of positive real zeros we are going to write. Then possible number of negative real zeros. Then if they are not positive or negative, what can be that? Possible number of complex zeros. If they are not real, they can be complex. So we said possible number of positive zeros is either 5 or 3 or 1. So if positive numbers are 5, negative real zeros possibility is only 0, right? So if there are total 5 positive real zeros, the complex numbers would be 0. If there are 3 positive real zeros, total number of zeros should be 5, right? Because the function's degree of f of x is what? 5. So total zeros should be 5. If we have 3 positive real zeros and none of them is negative real zero, so 2 of them should be complex. If one of the zeros is positive real zero and we have no negative real zero, so the complex zeros would be 4. Complex zeros always occur in the pairs, right? Because conjugate is also a 0. So this is the all possible table. Okay, let's do one more example so we can understand. Determine the number of possible positive zeros first. Let's try. Number of possible positive zeros. What do you have to check? You have to check change in the signs of the function. So from positive to -1, this is not changing. 2, not changing, not changing. So how many changes are happening? 2. So that is equal to number of changes in signs, which can be either 2 or an even number less than that, 0. So possible number of positive zeros is either 2 or 0. Now for number of possible negative zeros, what do you have to do? You have to first find g of negative x. Let's do that. 2 times negative x raised to power 6. Replace x by negative x in the function. Which is 2x raised to power 6 minus 5x raised to power 4. Positive because negative x cubed would be negative. Let's count number of sign changes in this. So 1, 2, no sign change, 3 and 4. So that means number of possible negative zeros is equal to number of sign changes in g of negative x, which is how many? 4, or even number less than that, 2 or 0. So that is the number of possible negative zeros of your given function. So let's analyze all of this. So let's look at the whole function one more time. We have a function whose degree is 6. That means it can have 6 zeros total. And it can have possible positive zeros are either 2 or 0. So, and number of possible negative zeros are 4, 2 or 0. So, let's say the positive zeros are 2 and the negative zeros are 4, then the complex zeros will be 0. Or let's say possibility for number of positive zeros is 0 and number of negative zeros is 4, and then complex zeros will be 2, because total of all these zeros, total number of zeros has to be 6, right? Or we can have this to be 0 and the negative zeros will be, that is a 2 is possible, and 2 complex zeros. Or this can be 0, this can be 2 and this can be 4. Or this can be 2, this can be 0 and this can be 4, or 0, 2 and 4. So these are all the possibilities. We just kind of analyze the whole situation. For g of x, if number of positive zeros are 2, then negative zeros will be 4 and number of complex zeros would be 0, and so on. So that is the kind of analysis using Descartes' rule.